Hello everyone, this is Teacher Maui of Kalayaan National High School. It's nice to see you again. At the end of the lesson, you will be able to apply what you have learned about the application of triangle congruence to construct angle bisectors. Keep on watching.
The objective of today's topic is applies triangle congruence to construct angle bisectors. Let us start our lesson by defining an angle bisector. An angle bisector is a ray that divides the angle into two congruent angles. So we have the illustration of angle ABC. Ray BD is the angle bisector. A point on the bisector of an angle is equidistant from the sides of the angle. So here, point D is equidistant to AD and CD. How to construct angle bisector using a protractor. Step 1. Draw an angle. So we have here angle ABC. Second step, measure the angle. But how to measure the angle? We need a protractor. So this is a device used to measure the opening of an angle. Okay, initially we have angle A, B, C. Side BC is the initial side, and side BA is the terminal side. So we're going to line up the initial side of the angle to the 0-degree line of the protractor. Next, line up the vertex with the midpoint of the protractor. Now, to find the measure of the angle, start from 0-degree until you reach the terminal side in our figure. Okay. So the measure of angle ABC is 160 degrees. Step 3. Divide the number of degrees in half. Then draw a point marking the measurement of the bisector. So 160 degrees divided by 2 equals 80 degrees. So let's mark on the 80 degrees part. Step 4. Draw a ray from the vertex of the angle through the 80 degrees mark. So we have now ray BD is the bisector of angle ABC. And we now have measure of angle ABD, which is equal to 80 degrees, and measure of angle CBD is equal to 80 degrees. Let us now study the angle bisectors of triangle. It is a line segment that divides an angle of a triangle into two equal parts. Here is the illustration. So we have triangle ABC and line segment AD bisects angle A, which forms two equal smaller angles. So we have angle BAD congruent to angle CAD. Every triangle has three angle bisectors. The figure shows the complete angle bisectors of triangle ABC. The three angle bisectors are line segment AD, line segment BE, and line segment CF. Point I is the point of intersection of the three angle bisectors, and it is called the incenter. The incenter is always at the center of a triangle. We are now ready to study the first example by applying what we have learned today. So this is the figure. Given line segment OB is the bisector of angle AOC. V lies on line segment OB. Prove that line segment VJ is congruent to line segment VM. So here's the proof. Statement number 1. Line segment OB is the bisector of angle AOC. V lies on line segment OB. So the reason is given. Statement number 2. So we have angle AOB is congruent to angle COB. So what is the reason? Definition of angle bisector. Third, line segment OC is perpendicular to line segment VJ. And line segment OA is perpendicular to line segment VM. Reason? Definition of a distance from a point to a line. Statement number 4. Angle VJO and angle VMO are right angles. Reason? Definition of perpendicularity. Fifth statement. Line segment OB is congruent to line segment OV. Reason? Reflexive property. Number 6 statement. Triangle VJO and triangle VMO are right triangles. Reason? Definition of right triangles. Statement number 7. Triangle VJO is congruent to triangle VMO. Reason? Hypotenuse acute angle theorem. Number 8 statement. Line segment VJ is congruent to line segment VM. Reason? CPC-TC, or congruent parts of congruent triangles are congruent. We have example number 2. We will use the figure to the right. Given angle MAT, line segment AN bisects angle MAT. Problem. If measure of angle MAN is equal to 3y minus 5, measure of angle TAN is equal to 2y plus 4, find the measure of angle MAT. So this is our solution. Since measure of angle MAN is congruent to the measure of angle TAN, we have the equation below. 3y minus 5 is equal to 2y plus 4. Now, the first step that we should do is to add 5 to both sides. So we have 3y minus 5 plus 5 is equal to 2y plus 4 plus 5. So we applied APE, or addition property of equality. And the result will be 3y equals 2y plus 9. Then next, we're going to apply subtraction property of equality by subtracting 2y to both sides of the equation. So we have 3y minus 2y is equal to 2y plus 9 minus 2y. And the result is y equal to 9. So we have now the value of y, which is equal to 9. Then next, we're going to substitute y equals 9 to either 3y minus 5 or 2y plus 4. After finding the value of y, which is equal to 9, let us substitute to both angle measures for checking sake. So measure of angle MAN is equal to 3y minus 5, and measure of angle TAN is equal to 2y plus 4. So 3 times the value of y, which is 9, minus 5. On the other hand, we have 2 times the value of y, which is 9, plus 4. Okay. Then, for the measure of angle MAN, this is equal to 22, because 3 times 9 is 27, minus 5 is 22. On the other hand, we have 2 times 9 is 18 plus 4, so we have 22. 22 equals 22. So meaning to say, these two angles are congruent in measure. So let's now proceed in getting the measure of the big angle, measure of angle MAT. And it is equal to the measure of angle MAN plus the measure of angle TAN. So 22 plus 22 equals 44. So therefore, the measure of angle MAT is equal to 44 degrees. Always remember, every angle has only one bisector, and every triangle has 3 angle bisectors.
That's all for today. Thank you for watching.